Hey everyone, welcome back. Are you ready to get our hands dirty digging into the world of rare earth refining? I know it doesn't exactly sound like the most thrilling topic, but trust me, it's way more important and honestly way more interesting than you might think.
Oh, it absolutely is. Once you start peeling back the layers, it's a real eye-opener.
It really is. And to help us get to the bottom of all this, we'll be taking a deep dive into a fascinating episode of the podcast, Digging Deeper, which you know I love. And they really get into the nitty-gritty of this whole process. It's kind of like this. You know how people say diamonds are rare?
Right.
Well, it turns out they're not actually that scarce. It's just that the supply is really tightly controlled, which makes them seem rare.
That's a great analogy. And that's kind of what's happening with rare earth elements, too. They're not actually that rare, but the refining process, that's where the real bottleneck is. That's what makes them so valuable, so strategically important, and, well, a little bit controversial.
Exactly. And that's what we're going to unpack today. So before we get too deep into the refining process, let's start with the basics. What exactly are rare earth elements?
Okay, so we're talking about a group of 17 elements. 15 of them are called lanthanides. They're kind of tucked away on that bottom row of the periodic table, you know, the one that often gets folded up and forgotten about.
Yeah, the island of misfit elements.
Exactly. And then there's scandium and yttrium, which are also lumped in with the rare earths, even though they're not technically lanthanides.
So 17 elements in total. But you said they're not actually that rare.
Nope, not really. The name is actually a bit misleading. They are found pretty much everywhere in the Earth's crust. The problem is they're not concentrated in large deposits like some other metals.
So it's not like you can just stumble upon a giant chunk of, say, neodymium just lying around.
I wish. No, they tend to be spread out in low concentrations, often mixed in with other minerals and rocks.
Okay, so I'm starting to see where the refining part comes in. Sounds like a bit of a headache to separate them all out.
It definitely can be. That's why the refining process is so crucial, and also why it's so complex and often pretty resource-intensive.
So take us back to the beginning. Where does this whole rare earth journey start?
Well, it all starts with mining, of course.
Yeah.
And there are three main minerals that are the primary sources of rare earth elements.
Hit me with them.
Okay, get ready for some tongue twisters. Bastnäsite, monazite, and xenotime.
Wow, those are definitely not words I use in everyday conversation. So what makes these minerals special? Why these and not others?
It all comes down to concentration. Those three minerals tend to have higher concentrations of rare earths compared to other rocks and minerals. That makes them, economically viable to mine and process, even though, to be fair, the concentrations are still relatively low compared to other metals.
Gotcha. So it's all about finding the richest veins, so to speak.
Yeah.
So we've got these ores fresh from the mine. What's the next step?
Well, first things first, you got to break down those big chunks of ore into something more manageable. So it's off to the crusher and grinder. They basically pulverize the ore into a fine powder.
Okay, so we're talking like sand-like consistency.
Yeah, pretty much. And once you've got that fine powder, it's time for the first stage of separation, which is a pretty neat process called flotation.
Flotation, that sounds kind of gentle for something involving, rocks and minerals and stuff.
It does, doesn't it? But it's actually very effective. Basically, they add chemicals to this watery mixture of ground up ore, and that creates a frothy, bubbly solution.
So it's like a rare earth bubble bath.
I like that. And the cool thing is, the rare earth minerals have specific properties that make them cling to those bubbles. So the bubbles, with the rare earths attached, rise to the top, while the unwanted rock and other stuff sinks to the bottom.
So it's like separating the wheat from the chaff, but with bubbles? That's pretty ingenious.
It is, and it's a surprisingly efficient way to get a more concentrated mix of rare earth minerals. But that's just the first step. We're not done separating just yet.
Okay, so what happens next?
Well, the next step is called leaching. And this is where things get a little bit more, shall we say, chemically intense.
Uh-oh, does this involve those, warning sign, skull and crossbones type chemicals?
Sometimes, yeah. Basically, they use strong acids or bases to dissolve the rare earths out of that concentrated ore we got from the flotation process. It's like using a really powerful solvent to, really extract those valuable elements.
But Digging Deeper mentioned that this process raises some environmental red flags.
And rightly so. The use of strong acids obviously can create some pretty nasty, toxic waste if it's not handled properly. And that's a big concern.
So what are companies doing to address that?
Well, some companies are starting to experiment with something called in situ leaching, and that's where they inject the acids directly into the ore deposit underground.
So less of a chemical bath and more of a targeted injection.
Yeah, you could say that. The idea is to minimize the impact on the surface environment, less waste to deal with above ground. But, it's still not a perfect solution.
Right, because you're still using those strong acids, just in a different way.
Exactly. And this is actually one of the reasons why China has become such a dominant player in the rare earth industry.
Because their environmental regulations haven't been as strict.
That's been a factor, yes. And in many other countries, those environmental regulations make the whole refining process much more expensive, more complex, and more difficult to get permits.
So it's been easier and cheaper for China to just go for it, full steam ahead.
To a certain extent, yes. And that's giving them a huge advantage in terms of, production capacity and cost. But we'll talk more about the geopolitical side of things a bit later.
Okay, so we've got this concentrated solution of rare earth elements,
Mm-hmm.
but I'm guessing they're still all mixed up together, right?
You got it. And that brings us to the really, really tricky part. Separating those individual elements.
I have a feeling this is where the real chemistry magic comes in.
It does. And it's also where things get incredibly challenging because remember, we're talking about elements with very, very similar chemical properties. It's like trying to separate grains of sand based on tiny, tiny differences in their color or texture.
Sounds like a nightmare.
It can be. The main technique they use is called solvent extraction. And it involves, imagine a whole series of tanks, each filled with a slightly different chemical solution.
Okay, I'm picturing it.
And then you basically move the rare earths from one tank to the next. And with each step, they separate a little bit more based on, how they react to the different solvents.
So it's like a very, very slow and meticulous sorting process.
Pretty much. And it can take hundreds of steps to get those elements to a high level of purity. It's really resource intensive and requires very precise control over the conditions.
Okay, so all that effort, all those tanks, all those chemicals, just to separate out a handful of elements.
That's the reality of rare earth refining. And it's another reason why it's such a costly and complex process.
All right, so after all that, we finally have our separated, purified rare earth elements. What form are they in at this point? Are they little nuggets of metal or something?
Not quite. They're typically in the form of oxides. So you'll have things like neodymium oxide, dysprosium oxide, and so on.
Oxides, huh? But we don't use oxides in most technologies, right? We need the pure metal.
You're absolutely right. So the final step in the refining process is converting those oxides into the pure metals. And they do that through a process called reduction.
Reduction. So are we shrinking them or something?
Not exactly. It basically involves using electricity to separate the metal from the oxygen in the oxide. They usually do this through molten salt electrolysis, which sounds very complicated, but it's basically just using electricity to break those bonds.
Okay, so we're zapping those metal atoms free.
Exactly. And once you've got those pure metals, they can be processed further, made into alloys and then used in all sorts of high-tech applications.
So that's the journey from mine to material. It's pretty amazing how much work, how much science, how much chemistry goes into getting those materials ready for use in our everyday lives. But it does sound like there are some big challenges along the way, especially with that, supply chain vulnerability that we touched on earlier.
Absolutely. And that's what we're going to explore in more detail in the next part of our deep dive. So stay tuned.
We'll be right back after a short break. Okay, so we've laid out this whole journey that these rare earth elements take from the mine to, eventually becoming part of our smartphones and electric cars and all these amazing technologies.
It really is an incredible process, isn't it?
It is. But we've also, highlighted some of the challenges along the way, especially when it comes to that whole, supply chain thing and the environmental impacts.
Right.
So I guess the big question now is, what's next? What does the future hold for rare earth refining? I mean, are we stuck with this kind of, status quo, or are things going to change?
Well, that's the million-dollar question. And honestly, I don't think anyone has a crystal ball, but I do think we're going to see some major shifts in the coming years.
Like what? What kind of shifts are we talking about?
Well, for one thing, I think there's going to be a continued push for, diversifying the supply chain.
Okay, so less reliance on just one country, less of a monopoly, so to speak.
Yeah, exactly. And we're already seeing this happening. There are investments being made in mining and refining projects in places like the U.S., Australia, Canada, even Greenland.
So spreading the risk, so to speak, not putting all our eggs in one basket.
Exactly. It just makes sense from a, both an economic and a national security standpoint. But it's not just about geography, it's also about making the whole refining process itself more sustainable.
Right, because even if we diversify the supply chain, if the refining process itself is still, environmentally damaging, then we haven't really solved the problem, have we?
We haven't. And that's why I think we're going to see a lot more emphasis on, developing and implementing those innovative technologies that we talked about earlier. Like, remember those ionic liquids?
Yeah, the magic potion for cleaner refining.
Exactly. And bioleaching. I mean, those are just the tip of the iceberg. I think we're going to see a lot more investment in, R&D in this area.
So it's not just about finding new places to mine and refine. It's about finding new ways to do it.
It's both. We need to, address both sides of the equation. And I think ultimately what we're going to see is a shift towards more closed loop systems.
Closed loop systems, okay. Explain that one to me.
So imagine a future where, the rare earths that are used in, say, old electric car batteries are then recovered and reused to make brand new batteries.
Okay, so instead of starting from scratch each time, we're basically recycling and reusing those materials over and over again.
Exactly, creating more of a, circular economy for these materials.
That sounds like a really good plan.
Yeah.
I mean, less waste, less need for new mining. Sign me up.
But let's talk about geopolitics for a second, because this whole shift in, rare earth production, I mean, could that lead to like more competition or even, conflict between countries?
It's definitely a possibility and something that, policymakers and analysts are keeping a close eye on, because rare earths are, essential for so many critical technologies, including defense and aerospace. So as the global demand for these materials continues to grow, control over those resources could become a major, bargaining chip on the world stage.
Right. So it's not just an economic issue, it's a national security issue as well.
It's both. And that's why you see governments, getting more involved in trying to secure their own rare earth supplies. Like the U.S., for example, has officially classified rare earth as, critical minerals, and they're investing a lot of money in boosting domestic production and recycling capabilities. So it sounds like we're entering this, new era for rare earths, where it's not just about the technology, it's also about, sustainability, innovation, and geopolitics. All these things are kind of intertwined.
I think that's a really insightful way to put it. And honestly, I think the decisions that we make in the next few years, both as individuals and as a, global community, are going to have a really big impact on, the environment, technology, and even global security.
It's a lot to consider. And listener, I want to leave you with this thought. Now that you've heard all this, about how complex this whole process is and how many challenges there are, what role do you think individuals can play in, shaping a more sustainable and equitable future for these materials?
That's a great question. And honestly, it's one that I think we all need to be asking ourselves, because it's easy to feel like, our individual actions don't really make a difference when we're talking about these huge global issues. But I really do believe that every little bit helps.
So what can we do? I mean, should we be thinking more carefully about, the products that we buy, supporting companies that are, prioritizing ethical sourcing and recycling?
Those are all fantastic places to start. We can also, advocate for policies that encourage more responsible innovation in this field. We can write to our elected officials. We can support organizations that are working on these issues. Let's make sure our voices are heard.
It really comes down to making conscious choices, doesn't it?
Yeah.
As consumers, as citizens, as global citizens, we all have a role to play in this.
Absolutely. We can all be part of the solution.
Okay, so we've talked a lot about the challenges and the, the complexities of rare earth refining, but I think it's time to, shift gears a bit and get to some questions from our amazing listeners, because you guys always come up with some really, really thought-provoking stuff.
I always look forward to the Q&A. It's always a chance to dive into some of those really specific questions that people have.
Okay, so first up, we have a question from Sarah in Seattle. And Sarah asks, with all this talk about finding alternatives to rare earth elements, are there any, promising substitutes on the horizon? So, Sarah, you're not alone in wondering this. A lot of people are, looking for those magic bullet solutions.
Right. It's kind of a holy grail in material science, right? Finding those perfect replacements for rare earth.
So what's the verdict? Are there any contenders out there?
Well, the thing is, rare earths have this, this really unique combination of properties. They're magnetic, they're optical, they have these really interesting chemical properties, and that makes them, really hard to replace completely.
So no easy swaps. Like we can't just, substitute sugar for honey in a recipe.
It's definitely not that straightforward, unfortunately. It really depends on the specific application. I mean, in some cases, yeah, we might be able to, redesign things or use different materials, but it's not always a, one-to-one replacement.
Gotcha. So it's kind of like, you might have a screwdriver that works great for most screws, but then you encounter this weird screw that needs a totally different tool.
That's a great way to put it. I mean, take magnets, for example. There's been a lot of research into, finding alternatives to neodymium magnets, which are used in, everything from electric cars to wind turbines. And there are some, promising alternatives out there, like iron nitride magnet.
Okay, so they might work in, some motors or some applications.
Right. But they might not be the best fit for, every single application. And even when we do find alternatives, they're often, trade-offs. They might be more expensive, or they might not be as efficient, or they might have, a bigger environmental impact.
No, it's not a simple solution.
It isn't. But, that doesn't mean we should stop looking.
Absolutely. Okay, let's move on to our next question. This one comes from David in Denver, and David is curious about bioleaching. He asks, are there any, real-world examples of this technology being used successfully? So, David, you're asking about those, microbes that can basically eat rocks and spit out rare earth elements.
It sounds like science fiction, doesn't it? But it's a real thing. And, it's still a relatively new technology, but there are some really promising examples out there.
Give us an example.
Okay, so there's this project in Australia where scientists are using bacteria to extract rare earths from mine tailings.
Mine tailings, okay. So that's like the leftover stuff from, the mining process.
Yeah, exactly. It's the stuff that's, typically just discarded as waste.
So we're talking about like getting a second harvest of rare earth elements from, what was essentially trash before.
Exactly. It's a great example of, creating that circular economy that we talked about earlier. And, bioleaching has this this added benefit of being much less energy intensive than traditional methods.
So win-win, right? Less waste, less energy consumption?
I think so. It has the potential to be, really transformative, not just for rare earths, but for, the entire mining industry.
Wow. Okay, we have time for one last question before we wrap things up, and this one comes from Maria in Madrid. Maria asks, what can I do as an individual to promote, responsible sourcing and use of rare earth elements? So, Maria, you're hitting on a really, really important point here. We've talked a lot about the big picture stuff. But what can we do as individuals?
I get this question a lot, and I think it's great that, people are asking it because it's easy to feel powerless in the face of these, these huge global challenges. But I mean, honestly, it really does come down to the choices that we make every day.
Okay, so give us some concrete examples. What can we actually do?
Well, I mean, first of all, just be mindful of your consumption habits. Do you really need that, that brand new smartphone or laptop? Or can your current one last a little bit longer?
So reduce, reuse, recycle.
Yes, exactly. I mean, every purchase we make sends a signal to the market. And, when you do need to replace your electronics, make sure to recycle them responsibly.
Yeah, don't just chuck them in the trash.
Right. A lot of, retailers and communities have e-waste collection programs. And that's really important because it ensures that those valuable rare earth elements can be recovered and reused instead of just ending up in a landfill.
So it's about, closing the loop.
Exactly. But we can also go beyond just our individual actions, right? We can support policies that promote responsible mining practices, that encourage those sustainable refining technologies, that incentivize recycling.
So vote with our wallets and vote at the ballot box.
Exactly. Let's make our voices heard and let our, elected officials know that we care about these issues.
I love that. We have more power than we think to, really shape the future of this industry.
We really do. It all starts with awareness, with, education, and with action.
Well said. And on that note, I think it's time to wrap things up. This has been an incredible deep dive into the world of rare earth refining. It's been eye-opening, to say the least.
It's a fascinating field, that's for sure. And it's one that I think is only going to become more important in the years to come.
Absolutely. A huge thank you to our expert for guiding us through this intricate landscape. And of course, a huge thank you to all of our listeners for, joining us on this adventure of discovery.
It's been my pleasure. Always happy to talk about rare earth.
Until next time, keep those questions coming, stay curious, and remember, knowledge is power.